Welcome, everyone. My name is Mr. Sullivan. I'm the Math Pro. Welcome to the Math Pro station, website, YouTube channel. I'm here to help you with all your math needs. This channel is designed specifically to discuss lessons in basic math, Algebra 1, Algebra 2, up through geometry and trig. If you have any questions or comments, put them in the comment section. I'll try to get back to you as soon as possible. We're just waiting here while my presentation loads. And I'm going to ask you guys to subscribe if you want to see more videos from me as I do my best job to explain these lessons to you. I'm going to start with Algebra 1 topics. And this lesson is just going to be explaining some basic math knowledge that you're going to need to know before you go into an algebra class. So some keywords up here in the right-hand corner for this lesson are expression versus equation. You need to know the difference between the two. Evaluate, simplify versus solve. Those are keywords that you need to know. What I've noticed is that students just see a math problem and they don't know what they're doing or which skill they're using or what task they're doing. So those are some of the most important things that you are going to need to know. You're going to need to identify. Once again, this is Mr. Sullivan, the Math Pro. Press the subscribe button if you want to hear or see more. So some definitions that you're going to need to know are, what is a variable? A variable is a letter or a symbol that represents a number or an unknown quantity. So when you start dealing with algebra, things that we don't know or we haven't identified yet, we call them a variable, and we represent that with letters. Most of the time you'll see the letter X, but we can use any letter. So in this expression, this is 8 plus n equals 12. The variable is n. This is the variable. That's the unknown part. We don't know what that is, and we have to try to find out what it is if they don't tell us what it is. A variable can use any letter of the alphabet, like n plus 5, x minus 7, and w minus 25. These are also called expressions when you have a letter and a number separated by an addition sign and another letter and a number. That means that on this side there's a term, that's one term, and on the other side of the addition sign, that's another term. So this one has two terms. This one has two terms, and this one has two terms as well. These operations separate each term. Algebraic expressions. Oh, let me try to make this smaller so you can see all of it. Algebraic expressions are a group of numbers, symbols, and variables that express an operation or a series of operations. So basically what this is saying is an algebraic expression is a string of letters or numbers. It's a math sentence without an equal sign. There's no equal sign in this expression, as you notice. It's just a string of letters and numbers. And we can separate the letters and numbers by with these addition and subtraction signs or multiplication and division into terms. This is one term, this is the second term. This is the first term, this is the second term. So there's two terms in each of those expressions. When we have an expression, what they're usually going to ask you to do is to evaluate an expression. That means they're going to tell you to plug something into the expression and get an answer out of it. So you evaluate an algebraic expression to find the value of an algebraic expression by substituting numbers for variables. That means you're going to take the variable out of the expression and put a number into the expression where the variable was. So in these examples, this first example says n plus 8. Let me try to use the rectangle box. If they tell you this part, if they tell you m equals 2, that means that you're going to take this m and you're going to plug it in to where, you're going to take the 2 and plug it into where the m is at. And that's where you get this part right here. The 2's been plugged in, and then you can evaluate the expression and get an answer of 10. So when they tell you to evaluate, they're going to give you what the letter equals. They're going to say m equals something or x equals something. You're going to take whatever it tells you that it equals, and you're going to plug it in or substitute it in, rewrite the problem, and then write the answer after you do your calculation. There's another example of this saying, this is the expression r minus 3. This is the part that you're going to be given in the direction. They're going to tell you that r equals 5 to evaluate. That means to plug in 5 to where r is, and that's this part right here. 5 minus 3 equals 2. Let me clear this out of here so I can. Okay, so some more definitions. Simplify. So the word simplifies. In some directions, you're going to be asked to simplify problems. Simplify means to combine like terms and complete all operations. Simplify means to put things that look alike together. I call them families. So in every family, there's a first name and a last name. So when we're talking about expressions, we can identify families by their first name and their last name. Okay, this says m equals 2. So in this expression right here, if they tell you that m equals 2, you can plug this in. You can look at this in a couple of different ways. First, I'm going to draw a line right here to separate this. They may ask you to combine like terms or evaluate. If they ask you to evaluate, then I can plug this m in, and then I'll get 2 plus 8. I'm still learning how to use this, so it's going to look a little sloppy, but hopefully you can get the point of what I'm trying to write. Plus 2. All I'm doing is plugging in the 2 and then evaluating. When I evaluate that, I'll get 8, 9, 10, 11, 12. So the answer to that would be 12. This is another way to write it, 2m plus 8. So we can put 2m since there's 2 m's, and that's another way to simplify that. So these are equivalent expressions. So you can write, when you plug it in, you can go 2 times 2 plus 8, or 4 plus 8 equals 12. Here's some keywords that lead for addition. So when you have a word problem, you're going to need to pick out keywords. If you know these keywords, you'll easily be able to find out what operation you're going to need to use for the word problem. So learn these keywords. Anytime you see addition, another word for addition is sum. That's the answer to an addition problem. More than, increased, or plus, all together as well. You're going to need become familiar with these words, and they relate to addition. So if you're reading a word problem and you go through the word problem and you see increased, you know you're going to use addition somewhere in the word problem. Or if you see plus, you're going to use addition. Or altogether, you're going to be adding something. Just like subtraction has words that are connected to it as well, and those are decreased, means going down, less or less than, difference, minus, and how many more. That's key. Some problems, those are the tricky problems. It'll say how many more. A lot of students get confused. So you can use subtraction with how many more when you see how many more in a word problem. You're going to need to be able to write algebraic expressions into word phrases And you're going to also have to be able to go backwards and read word phrases and write them into algebraic expressions. You have to do both. So you have to go from writing English sentences to math sentences, and you have to be able to write a math sentence into an English sentence by using the keywords that we went over. And we didn't go over multiplication and division yet, but that will come up. The first one says 10 more than. So the key word, always pull out the key word. It's more than. That tells me, oops, let me erase that. More than means I'm going to be using addition in this. Also, it says a number. If they say a number, then that means I'm going to use a variable. They didn't tell me what number. So that means I'm going to use a variable, any variable that I want. They didn't tell me what variable. So I'm going to say 10 more than. I can write it like this, 10 more than. So that means I'm going to be adding 10 more than a number. So I'm going to put X because I don't know what that number is. You can put any number that any letter that you want, but I'm using X there. This one says a number decreased. A number is important, so I'm going to put all underline decreased. That's important. And then it's a little sloppy. Let me clear it out the way. My hand is dragging here, so decrease. That's a little bit better. There we go. Decrease means I'm subtracting a number. So let me use, I don't know, T. I can use any letter. If they just tell you a number, just put any letter that you want. T. Decrease by 5. That means I'm going to subtract 5. Minus 5. There we go. And that's how that would be written from English sentence to a math sentence, an algebraic expression. Section. And then you're going to finish the rest in the same way. 6 less than a number, you're going to use subtraction. The key word here is less than, so you're going to use subtraction. The next one is a number increased by. Increased, you're going to write addition. This is going to be an addition problem. And this is the sum of a number. The sum means addition again. Now I'm going to scroll through this because I couldn't get the formatting quite right. So I'll just scroll through this. This one says a number S. Also, this does tell you what number they want you to use. So if they tell you what letter, not number, what letter they want you to use, then you're going to use this letter. So it says a number S plus 2. So you're going to write S. They're telling you it. You can't write any letter that you want on that one. Plus 2. And that would be the answer to that one. If it was a little more, that's supposed to be a 2 right there. And then so on. So a number decreased by, so decrease means subtraction. 31 less than means subtraction. You're going to write 31 minus X. They didn't tell you what letter, so they're just saying 31 minus a number. So you just put X or R or W, whatever you want. This one says a number. Okay, so a number. So this one's going to, I would write X. Oh, wait, hold on. It says a number B. Oh, it's telling you what letter to use. So I can't use the letter that I want to use. So B is what I'm going to use. Increase means add by 7. So this one would be B plus 7. And B plus 7. That's that. That's not 6, that's B. And the last one, a sum means add. So you're going to add a number. They don't tell you what number that is or what letter they want you to write. So you put X or R, whatever letter you want. And 6. So I will do X plus 6. That's that one. X plus 6. Okay. Okay. Evaluate. If they tell you to evaluate each expression when they give you what the letter equals, x equals 10 here, you're going to substitute the 10 into each one of these x's and get an answer. So when you substitute, means to take out the x and put in the number. Take out the x and put in the 10, and then do your math. So 10 plus 8 is going to be 18. 10 plus 49 is 59. 10 plus 10 is 20. 10 minus 10 is going to be 0. And 10 minus 7 is going to be 3. And 42 minus 10 is 32. In algebra, you're going to be working with a lot of tables. On the left side of the table, you're going to have inputs, and on the right side of the table are going to be outputs. Inputs, sometimes they're given to you, sometimes they're not. If they don't give you what the inputs are, you make up the inputs whatever you want. In this case, they gave us these inputs on the left side. The inputs are the numbers that we're going to put into the equation in this top box and then get an answer. You're going to substitute the numbers into this equation and get an answer for all of these. So for the first one, you're going to substitute 5 in for n and get an answer to 2. So 5 minus 3 equals 2. When you substitute 5 in for n there, and so on. You're substituting you're substituting the number on the left side into n to get the answers on this side. So for this one, 10, if I substitute that in for n, 10 minus 3, that equals 7. 21, so on here. Next problem, 5. If I substitute that in, I'll get 11. If I substitute the 10 in, I'll get 16. If I substitute the 21 in, I'll get 27. And when I replace or substitute the 32, I'll get 38. So you're going to be asked to write an algebraic expression for these situations. So you're supposed to be able to write an algebraic expression when you read an English math sentence, and you're supposed to be able to read an English math sentence and write an algebraic expression. So you're supposed to go back and forth. So Scott's brother is 2 years younger than Scott. That tells me younger than is key. Oops. That tells me that I'm going to be, I did the same thing. That's the key word there, younger than. Here, the sum of two numbers is 12. Okay, so that tells me that I'm going to be adding two numbers. The sum of two numbers is 12. This one, the difference is subtraction. That tells me I'm going to be subtracting two numbers to equal 5. Is in math means equal. So I'm pointing out these keywords for a reason, because you're going to be asked to identify them over and over again. Okay, and that's how you write those out. It's a little sloppy there. So real quickly, I'm going to go over just a couple more examples, but I just want to remind you to press the subscribe button for more, or visit these two websites if you want some more information. So a couple of key examples. The main goal of this presentation or this lesson that I want you to understand is the difference between simplify and solve. When the directions say simplify, that means you're putting things together or combining like terms or putting families together. When they're asking you to solve, they're asking you to come up with one answer. They're asking you to solve for one letter for x to find out what x equals. So in the top portion, I'm going to combine like terms or put families together. Here, that term is just like that term. Remember, the terms are separated by the addition, subtraction, multiplication, or division sign. So in this term and this term, they're like each other because they have the same first name and the same last name. I call this the first name, and the letter is the last name in that term. So you have a first name and a last name. First name, last name. If they have the same last name, which they do, I can put them together. So 2 and 5 I put together to equal 7x. And then what's left, these two are like each other. They have the same first name and they don't have a last name. So they're in the same family. And I keep whatever signs there are. Those signs are important. I'm done there because there's nothing else to combine. The way that I know I'm done with an expression, I won't be able to add anything. I won't be able to put any families together anymore. I won't be able to combine like terms. So I'm done there. In this problem, there's an equal sign. Whenever there's an equal sign, that tells me I'm going to solve. That means automatically I'm going to separate the problem, like I taught in my solving simple equations lesson. And I'm going to get the x by itself. I'm going to start on the side of the letter, start on the left side, and get rid of what's not close to the letter, which is the 3. I'm going to do the opposite operation of the 3. I'm not looking at the plus sign, but I'm looking at the sign of the 3, which is positive. That's why I'm going to subtract 3 first. So to a quick review, I'm going to start on the side of the letter, which is the left side, and I'm going to get rid of what is not close to the letter, that 3, by doing the opposite on both sides. Whatever I do to one side, I have to do to the other. Here, it cancels out. Bring the 2x down. Do the math on this part. 12 minus 3 is 9. I still haven't gotten the letter by itself. I still need to isolate the x by doing the opposite operation. The operation that's going on here between this 2 and this x is multiplication. There's an invisible multiplication sign. This means 2 times x. So in order to isolate that, I do the opposite of multiplication, which is division on both sides. So I'm going to divide this by 2 and divide this by 2. That cancels out. Now I bring the x down, and x is going to equal 9 over 2. And we should probably write this in a mixed fraction, or we try to reduce it. If I write this in a mixed fraction, 2 goes into 9 4 times. And what's left over? 1/2. There's the answer. So as you notice, in the top problem where we simplify, we don't get one answer. We get an expression. In this bottom part, we were able to get one answer. By the way, that equals x. So x equals 4 1/2. X equals 4 1/2. That's the answer. So I'll remind you, subscribe, press that button. I'll be making videos every day. Put questions and comments in the comment section, and visit these websites if you want some more information. Thanks. Hope to see you soon.